Hello, welcome to another module in this online course, Strategy and Introduction to Game Theory. And today let us start looking at yet another different game, which is a market game between two different firms or two different companies producing two different goods in a market. This game is known as a standard game and a very popular and a very established game known as the Cournot Duopoly. And as we have seen various different examples of scenarios, of real life scenarios that can be modeled as games. This game, which is the Cournot Duopoly, as the name implies, it talks about a duopoly. As we are all familiar, a duopoly is a competition between a market competition between two firms. A duopoly is a competition where two firms are controlling an entire market by producing two kinds of goods which are different but yet similar, in the sense they have a similar utility or similar applicability. And Cournot is the name of the economist who first proposed this game in 1838. So Cournot is an economist who proposed this game in 1838 to study this interaction in a duopoly when there are two firms competing to produce a goods. So the scenario that we are going to consider is a market game. So we are going to look at a market game or a strategic interaction market, that is a strategic interaction, a market based strategic interaction, a competition between two firms which are producing two goods which are closely related. They are producing such that the consumers can substitute one good for the other, that is, the consumers do not have a strong preference for one versus the other. For instance, consider an example of two different soft drinks available in a market which are closely related, or different soaps available in the market where consumers do not have a strong preference of one soap for the other. And such goods which can be almost readily substituted for the other are also known as strategic substitutes. Such goods which are what are strategic substitutes? Strategic substitute are two goods which are closely related to the other in applicability and functionality, so that the consumers do not have a strong preference for one versus the another, can more or less readily substitute one for the other, such that two popular soft drinks or popular soaps in a market and so on. So these are often used to model the fast moving consumer goods where typically people do not have a strong preference for one versus the other. And in a Cournot game, we are looking at a competition between two different firms in a marketplace. This is a duopoly. So we are considering two different firms in the market which are producing such goods which are basically strategic substitutes, and what is the interaction between these two different firms which are competing in the marketplace to sell the good or to capture the market and sell these goods to the consumers. So let us look at this game. We have two firms, F1 and F2, which are, let us say, producing quantities S1, S2 of these strategic substitutes. So what are the actions? So these S1 and S2, these are the actions, or these are the strategies, or what is that is the strategy of each firm is to determine what is the quantity of the good to produce. So S1 is the action of firm 1, S2 is the action of firm 2. So these are the actions So, these are the actions of the two firms, that is to determine how much quantity to produce of the good, right. And also again, as we have seen previously in the tragedy of commons example, again these quantities need not be restricted to a discrete set of quantities, can possibly take an infinite set of values, as we are going to see shortly, right. So, this is a duopoly, it is a competition between two firms, and the two firms are competing by producing these different quantities of these goods. Firm 1 is producing S1 of the good, firm 2 is producing S2 of the good, and these two goods are strategic substitutes, in the sense one each can be substituted for the other by the consumer more or less readily. So, in this way there is an interaction, there is a competition between these two firms in the marketplace to capture more of the market, not only to capture more of the market, but to increase the profit corresponding to the quantity produced. And what are the utility functions? Well, the utility function for each firm can be modeled as follows. First, we are going to model the demand function for this good. Let the demand function, or let the price function which is the price of the good as a function of S1 comma S2, this is the price per unit, is given as A minus B times S1 plus S2. So, what were we saying? The price of the function is, or the price per unit of good is A minus B times S1 and S2, where this A and B, these are positive constants, these depend on the particular good and the market. And also you look at this, the price is decreasing with the quantity, the price is decreasing with the quantity, and this is also termed as an inverse demand function, which is basically the modeling of the price with the total quantity, that is, as the total quantity of the good is increasing, then the price per unit is decreasing. Also interestingly, when the quantity, it only depends on the total quantity S1 plus S2 of the good produced, that is, as S1, it does not depend on S1 or S2, I mean as the total quantity S1 plus S2 is increasing, the price is decreasing. This shows that even if S1 increases or S2 increases, the price will decrease, because as we said, these two goods are strategic substitutes, one can be more or less readily substituted for the other, and that is reflected in the price function or the inverse demand price function, where the price is decreasing as the total quantity is increasing, and more importantly the price is decreasing is depending only on S1 plus S2, that is the total quantity of good 1 and good 2 produced by these two different firms F1 and F2, right. And further, let the cost per unit, let be given by C, which is another constant. So, let the cost per unit in this game be given by C, right. So, the cost per unit produced is given by C. So, the total cost of firm 1 and firm 2, since firm 1 is producing S1 units, it is C times S1, since firm 2 is producing S2 units, the total cost is C times S2. So, cost, total cost of firm 1 is C times S1, total cost for F2 equals C times S2. Since the cost per unit is C, total cost, and firm 1 is producing quantity S1, total cost is C times S1, firm 2 is producing quantity S2, so total cost is C times S2. And therefore, now the payoff for each firm can be obtained as follows: U1 of S1 comma S2 equals total revenue minus total cost. Total revenue is the price per unit times quantity or the number of units minus the total cost. We have already seen that the price per unit is A minus B times S1 plus S2. So, this is A minus B times S1 plus S2 into the quantity S1 minus the total cost, which is C times S1. So, the total profit for firm 1 is the price per unit times the quantity minus the total cost, which is equal to A minus B times S1 plus S2 times the quantity S1 minus C S1. This can be further simplified as A minus C minus B times S1 plus S2 times S1. So, to again write this clearly, we have U1 of S1 comma S2, which is the total profit of firm 1 equals S1 into A minus C minus B times S1 plus S2, right. And similarly, now if you look at the payoff of firm 2, I can write similarly derive, since this game is symmetric, this is S2 times A minus C minus B times S1 plus S2, and therefore, now you can see this is a game, this is a strategic interaction between the firms F1 and F2, because their profit depends not only on the quantity. For instance, the profit of firm 1 depends not only on the quantity S1 produced by it, but also depends on the quantity S2 produced by firm 2. Similarly, the profit of firm 2 depends not only on the quantity S2 produced by it, but also on the quantity S1 produced by its competitor. Therefore, we have these two different utility functions, and now we have formulated this in terms of a game or a strategic interaction, or in fact, this game is known as a duopoly, and this, as we already said, this game is the Cournot Duopoly, which was proposed by the French economist or mathematician Cournot, right. And in this game, we are going to capture what is the behavior of these two firms, what are the quantities produced by these two firms when they are competing in this market by producing this good, which, as we said, is a strategic substitute, which are more or less different brand name, but more or less closely related in utility, right. Therefore, now how do we analyze this game? Now we have the two different actions S1 and S2, and now how do we analyze this game? Again, we have said the quantities produced can be continuous, they need not be a finite set of quantities. So, we are considering an infinite possible set of quantities, that is a continuous, that is set of quantities S1 and S2 can be real numbers belonging to a continuous interval, right. So, we cannot draw a game table, and as we have seen previously in the example of the tragedy of commons, we can now use differential calculus to first find the best response and then find the Nash equilibrium. And therefore, to find the best response of firm 1, to find best response S1 star of firm 1, differentiate with respect to S1 and set equal to 0, right. That is how, remember, we found the best response of each agent or each player in the tragedy of commons, because these are continuous functions, differentiable functions with respect to S1 and S2. To find the best response S1, I can differentiate it with respect to S1 and set it equal to 0. We have therefore U1 of S1 comma S2 equals, well, S1 into A minus B or A minus C minus B into S1 plus S2, which is equal to A times S1 minus C times S1 minus B times S1 square minus B times S1 S2. Therefore, now if I differentiate this with respect to S1, I have dou U1 by dou S1 equals A minus C minus 2B S1 minus B S2, which I have to equate to 0, and therefore, I obtain the best response S1 star equals A minus C minus B S2 divided by 2B. Therefore, I have the best response given as best response S1 star given as S1 star. Let me write this down again clearly. S1 star equals A minus C minus B S2 divided by 2B, and in fact, this is S1 star equals BR1 S2. This is S1 star, which is the best response of firm 1, or which is the best response quantity of firm 1 to be produced in response to the quantity is S2 produced by firm 2. And how did we find it? We found it by differentiating the payoff function and equating to 0 to find that S1 star where the payoff is maximized, and therefore, this is indeed the best response. Now, again using symmetry, the best response S2 star of firm 2 is given as S2 star equals A minus B minus S1 divided by 2B. This is the best response to the quantity S1 produced by firm 1. And therefore, now what have we done? We have successfully characterized the best responses for both these firms. And now, once you have characterized the best responses, we can find the Nash equilibrium now, because we know that the Nash equilibrium is where these best responses intersect. Therefore, the Nash equilibrium NE is where the best responses intersect, that is S1 star is best response 1 of S2 star and S2 star equals best response 2 of S1 star. Therefore, we have each player playing his best response, and that characterizes the Nash equilibrium, and therefore, now I can write down the system of equations to solve the Nash equilibrium as S1 star equals A minus C minus 2B S2 star divided by 2B, and S2 star equals A minus C minus 2B S1 star divided by 2B. This holds true only at NE, since each is playing the best response. Now, again, if I call this as equation number 2 and if I call this as equation number 1, I can substitute the expression for S2 star from equation number 2 in equation number 1. I have S1 star equals A minus C divided by 2B minus half S2 star, and substituting for S2 star, I have A minus C by 2B minus half of A minus C by 2B minus half of S1 star, and solving this I have, well, 3 by 4 S1 star equals A minus C divided by 4B, which implies S1 star equals A minus C divided by 3B. Therefore, I get the Nash equilibrium quantity S1 star equals A minus C by 3B. Solving these two equations, I get S1 star equals A minus C by 3B and also by symmetry you can again see that S2 star the quantity is S1 star, and therefore, these are the Nash equilibrium quantities S1 star, S2 star. These are Nash equilibrium quantities. So, the Nash equilibrium is A minus C by 3B comma A minus C by 3B, where this is the quantity S1 star produced by firm 1 and this is the quantity S2 star produced by firm 2 in equilibrium in this Cournot duopoly. So, this is the Nash equilibrium of the Cournot. This is the Nash equilibrium of the Cournot duopoly again. Now, let us try to represent this graphically to understand this better. Let us take typical values. Let us say A equals 10, B equals, C equals, let us say 1. Then what we have is we have S1 star equals A minus C minus BS2 divided by 2B, which gives me basically 4.5 minus half S2. So, I can write S1 star equals 4.5 minus half S2, taking these values A equal to 10, B equal to C equal to 1. Similarly, S2 star equals 4.5 minus half S1. Let me try to draw it graphically. On the x axis I am representing the quantity S1, on the y axis I am representing the quantity S2. So, this is 10, let us say I am trying to be as accurate as possible. Of course, I am not using a scale, so I cannot be very accurate in these measurements. I am trying to approximately mark these things. Now, you can look at on the x axis I have S1, on the y axis I have S2, and S1 star equals 4.5 minus half S2. So, S1 star, let me write it here, S1 star equals 4.5 minus half S2. So, if S2 is equal to 9 somewhere over here, if S2 equals 9, then we have S1 star is equal to 0. On the other hand, if S2 is equal to 0, then we have S1 star is equal to 4.5, which is probably somewhere over here, and let me join these using a line, and therefore, now I have S1 star, this represents S1 star, which is equal to the best response 1 for any quantity S2. So, what I have drawn is the best response S1 star as a function of S2. If S2 is equal to 9, the best response S1 star is equal to 0. If S2 is equal to 0, the best response S1 star is equal to 4.5. Similarly, we can draw it for S2 star, and that line which is S2 star, remember, equals 4.5 minus half S1. If S1 is equal to 9, best response S2 star is 0, and if S1 is equal to 0, best response is S2 star is equal to 4.5. That will look something like this. So, this is the best response S2 star equals best response 2 of S1, and these are the best responses of both the firms. This is the best response of firm 1, S1 star is the best response of firm 1, S2 star is the best response of firm 2 as a function of S1, and the point where both of these intersect, that is S1 star equal to S2 star, in this case is equal to A minus C by 3B, which is equal to 10 minus 1 by 3 is equal to 3. So, this point, which is 3 comma 3, we are saying is the Nash equilibrium. So, this point is the Nash equilibrium of this game. This point is the Nash equilibrium of this Cournot duopoly game. So, this point we are saying is basically the point that is 3 comma 3, we are saying this is the Nash equilibrium is of this Cournot duopoly game. So, what we have done is we have looked at yet another interesting example of a market competition between two firms which are producing strategic substitutes, and we said this is also termed as a duopoly, and we have modeled the profit functions of both these firms, and from these profit functions or from these utility functions we have derived the best responses, and finding the place or finding the best response, the intersection of these best responses, we found the Nash equilibrium, we found the Nash equilibrium quantities of both the Nash equilibrium quantities, and the Nash equilibrium quantities as we found are A minus C by 3B, A minus C by 3B for both these firms, and when A is equal to 10 and B equal to C equal to 1, this Nash equilibrium is 3 comma 3. All right. So, at this point let us stop, and we will continue our discussion to study different properties of this Cournot duopoly in the next module. Thank you.